everyone, so welcome to my YouTube channel. Chalo bhaiya, chalo ji. Okay guys, so before starting today's class, I will tell you that this class is going to be little bit lengthy. Bhaiya lamba hoga classes, okay. And this is like class 11th structure of atom. It is a continuation, video number 3. So all you know from where to get the video. Go to the channel, go to the playlist. In that you will see the class 11 chemistry. Click that. Then video 1 of structure of atom, video 2 of structure of atom. This is the video 3 for structure of atom. So bhaiya, give the water bottle and everything guys. This video is going to be little bit lengthy and interesting also. Okay, so till now we have studied this Rutherford, J.J. Thomson. Before Rutherford we have seen this also, X-rays and all. Okay, so this part Henry Becquerel, and then this Wilhelm Röntgen. So these all we saw, which is very important for your competitive examination. Board examination is there, but competitive में ज़्यादा important है भैया. Okay, so we saw all this gibberish things and all, and I hope you all are doing well, guys. Yes, sir, we all are doing good, sir. Now, guys, we are starting with the Bohr's model of atom. See, when we will come for the Bohr's model of atom, the Bohr's model of atom is very simple and it's not that much complicated, but it's a lengthy. Okay. So see, Bohr model of atom, what he says, first of all, Bohr model of atom, he says that dual character of electromagnetic radiation. What he says that, see, Bohr's, see guys, we know that the basic concept, like in the center nucleus is present, right? And then around the nucleus the electrons are rotating, correct? See, this we already studied in the like 10th standard also. Okay. In the like atom center is what? Nucleus, correct? Nucleus, around the nucleus there is a orbit, or we call it as a shell, correct? Yes sir. Then in the orbit or in the shell electrons will rotate or electrons will revolve. Yes sir. And we know guys, K shell, L shell, M shell, N shell, correct? So each and every shell have its own energy. Each and every shell have its own energy. K shell less energy, L shell more energy, M shell more energy, N shell higher energy. So every shell is having different energy, correct? So that's why suppose electron is in, देखो रे प्यारे, अरे ओ भैया देखो जी, suppose guys this is the end, this is a nucleus, this is the orbit, the orbit, and guys see, we know in the orbit electrons will rotate. Okay, now suppose this is the first orbit. If electron wants to jump from first orbit to second orbit, what is happening? First orbit is the lower orbit, so lower orbit will have a lower energy, and this is a second orbit. Second orbit means higher orbit, so higher orbit will have a higher energy. So when electron jump from lower energy to higher energy, what will happen? Electron will gain the energy and then it will jump from lower to higher. Same if suppose electron is in second orbit and it want to jump to third orbit. The second orbit is what? अरे बोलो रे प्यारे, second orbit sir, second orbit ना lower orbit है. It want to jump to third orbit. Third orbit क्या है sir? Third orbit is higher orbit. So from lower orbit, if electron wants to jump to higher orbit, electron requires energy. And same thing what will happen? If suppose electron is in third orbit, it wants to move to the second orbit. So what is happening? From higher orbit it is going to lower orbit. So from higher orbit to lower orbit, we will not say jump, we will say it fall. Not in the love, it fall. Okay, it falls from third orbit to second orbit. Whenever it's falling, it releases energy, right? Whenever you are falling in love, you releases the happiness energy, happy energy. So like that, when electron is in the third orbit and when it is falling to the second orbit, it will not jump to the second orbit. If you are writing electron jumps from higher to lower, kidnap. Electron will not jump, electron will fall from higher orbit to lower orbit. Means if suppose electron is revolving in third orbit, it will fall from third orbit to second orbit. Means from higher orbit to lower orbit it falls. The falls means what will happen? It releases energy. Same, if electron is in second orbit, if it want to go to third orbit, means what? From lower orbit it is going to higher orbit. So electron will jump. Jumping means what? It requires energy. Okay, and every orbit have a different energies. Okay, fine. Now see guys, what happened is here guys, we should not have to write anything. If you want you can write, otherwise we have to just underline whatever the things I underlined here. So guys, we are studying about the Bohr's model of an atom. See, Bohr's model of an atom we call as development. Why development? Because he saw that okay, JJ Baba did like this, then JJ Thomson did. We'll say na चार लोग क्या कहेंगे. In our life also, if you do the something, there are people, the groups of people, they will start torturing you. This is wrong. No, this is also wrong. This is also wrong. Oh, all is wrong. So what will happen? Thomson did, Rutherford came. Before Rutherford, that Bakwas. No, first Dalton. Dalton did something. Thomson came. After Thomson, Roentgen, Henry Becquerel, they did their observation, their experiment. Then Rutherford came. After Rutherford, Bohr came. So what is happening? Development. It's showing a new things. So new things means what? Development. So that's why development leading to Bohr's model of atom. Whatever we learned before, we are going to development in that. So as the development will happen, we will say it lead to the Bohr's model of atom. Okay. So Bohr's model of atom, what he sees? Now he sees and he said that Bohr's model of atom, he says two things. First thing, he said that dual character of electromagnetic radiation. See, in Rutherford, before Rutherford, what we learned? X-rays, right? Alpha rays, beta rays, gamma rays. Rays means what? Rays is nothing but like a radiation. Correct? We know guys, Roentgen what it did? Roentgen discovered the X-ray. Correct? So X-ray, if you want to do the X-ray, we have to do the X-ray of hard solid object. Hard, heavy, solid object. Okay, if it is a soft object and all, we cannot able to do the X-ray, because X-ray means what? The rays, the high rays will penetrate into our body and it will hit to the solid heavy object, that is what? Bone, and the image will come out. That's what will happen in X-ray, right? So X-ray means what? We are releasing the rays. The rays means what? It's later on discovered like a rays, like a radiation. Because what will happen? Radiation will come, right? So that's why Bohr's, what the Bohr says, that first thing he said that dual nature of electromagnetic radiation. Guys, see, electromagnetic means we are getting a radiation. We are getting electromagnetic radiation means what? We are getting a radiation from where? Where electric field and magnetic field both are present. So electro means what? Electric field. Magnetic means what? Magnetic field. So electromagnetic radiation means we are getting a radiation where electric and magnetic field both are present. Not only the electric, not only the magnetic. Electric and magnetic field both are present. Babu bhaiya log. So that's what he said, dual nature of electromagnetic radiation. What is the dual nature? Dual nature means it shows the two things. What? Which means that radiation possesses both wave-like and particle-like properties. So what the Bohr says that? Bohr says that electromagnetic radiation, because guys, before we are studying about the things, right? Electric field and magnetic field. Electric field and magnetic field. Then only the deviation will happen. If electric field and magnetic field is not there, it will go in a straight line. Correct? We studied before. If you know, you know. Okay, chalo re pyare dekho. Electric field and magnetic field both should be there. So electric means electromagnetic means magnetic. So electromagnetic means electromagnetic radiation means the radiation we are getting from electric field and magnetic field. That's called electromagnetic radiation. Okay. So electromagnetic radiation, it starts showing dual nature. So what is the dual nature? First thing they said, which means that radiation possesses wave-like. Correct? Like this wave. See here, this is a wave, like this wave. Correct? Wave like and particle like alpha particles, right? Rutherford took the alpha particles, which is helium, and he start hitting. The alpha particles will move in a straight line until unless something is there, it will deflect in also in a straight line. Okay, but wave, it will go like this. Okay, so that's why Bohr's model, what he discovered, first thing discovered the dual nature of a dual character of electromagnetic radiation. What is the dual character? It shows the radiation shows both wave like and particle like properties. It will show the both wave properties like this blue color and red color, wave like properties, and the particle means straight, it will go particle like property, that it can go straight or it can go like a wave. Okay, so this is the dual character of electromagnetic radiation, which means radiation possesses both wave like and particle like properties. Second is what? Experimental result regarding atomic spectra. We are going to learn about in future topic. Atomic spectra. Spectra means, you know, like this. See, different spectrum, you know, right? Spectrum. So different colors, bandwidth. Okay, which we will study in the future classes. So this is what, guys, these 2 points is about the Bohr's model. What the Bohr's model says that. Okay, if they will ask in the examination Bohr's model of atom, you have to write these 2 points. That's it. So first point we are going to learn here, guys, wave nature of electromagnetic radiation, because we know that electromagnetic radiation, the radiation starts showing dual character. First is what? Wave, and second is particle like character. Okay, wave like properties and particle like properties, correct? So see, we will study about the wave nature of electromagnetic radiation. So what is the wave nature of electromagnetic radiation? Let's see. What they studied is, they studied that absorption and emission of radiation by heated object. These are called thermal radiation. Okay. So first we are going to study about wave nature of electromagnetic radiation. Okay. So wave nature of electromagnetic radiation, what will happen now? If we'll take a thermal object means heat. Thermal means what? Heat. So heated object. If you are taking, suppose this is my heated object. So if I will take this heated object, guys, we know from heated object also we will get a radiation, correct? If you will take, suppose this is a if I inside this I will fill a hot boiling water. So what will happen? When you will touch outside, you will feel it heat. Okay, if you will keep the hand, you know, little bit far also, you will feel the heat. Why? Because the heat is flowing in a radiation form. Heat is flowing in a radiation form. Correct? So what will happen? Suppose if you will take iron rod, you will heat the iron rod. So if you will bring the hand nearby that iron rod, you will feel the heat. Why? Because heat is flowing. Heat is flowing in a form of radiation. So what is this object? Heated object. So object is heated. So if this heated object, what will happen? See, understand what will happen. Suppose this is the iron rod. Okay. First I will take the iron rod normal. Temperature is what? Normal room temperature. I will take the iron rod as a normal room temperature. So what will happen? First I will heat. Guys, in heating what will happen? Are bolo re pyare bolo ji. In heating, yes, in heating we will give the heat to the object. In heating what we are doing? We are giving the heat to the object. When we give heat to the object, this object will absorb the heat. Correct? So what will happen? First I will take a normal object, means at room temperature. Okay, then what I do, I start heating this object. When I start hitting this object, so what will happen? This object will start absorbing the heat. Correct? This object, what it will do is start absorbing the heat. When this object will start absorbing the heat, this object will called as heated object. Why it is called a heated object? Because I am giving the heat to this object, and this object starts absorbing the heat. When this object starts absorbing the heat, this object is called as heated object, because its object is what? Getting heated. So for any object to get heat, what is the first thing is, we have to give the heat, and this object should have to absorb the heat. We are giving the heat, that's fine, but this object should have to absorb the heat. If this object will absorb the heat, what will happen? This object is called as heated object. And when this is called as heated object, first it will absorb the heat, it's become heated object. Once it will become heated object, it will release the heat, because what will happen, surrounding of this heated object you will also feel the heat. Why? Because it was normal, then later on what happened, this object absorbed the heat. As this object absorbed the heat, this object is called as heated object. So once this object will become heated object, this object will start releasing the radiation. Which radiation? Heat radiation. Okay, thermal radiation. Heat means what? Thermal. So thermal radiation. So when you will go, like, surrounding of this object, you will start feeling the heat. Why? Because first it absorbed the heat, it's become heated object. Once it become heated object, then it start releasing the heat. Heat means what? Thermal, and it's a radiation, so it's become a thermal radiation. That's what it says, that what is studied? Absorption. First it will absorb. What it will absorb? Heat. After absorbing, what it will do? Emission of radiation. Once it will absorb the heat, it will do a emission of radiation. Correct? What radiation? Emission of radiation by heated object, because once you will absorb the heat, it will become heated. Once it will absorb the heat, it will become heated, so it's called heated object. So absorption and emission of what? It will absorb and then it will emit the radiation by heated object. So this radiation is called as thermal radiation, because when it will release the radiation is heat. Radiation is heated. So heated means what? Thermal. So that's called thermal radiation. Okay, I hope understand. Now guys, we know electromagnetic waves of various frequency and wavelength. Guys, we know that every waves will have different frequency, different wavelength. Correct? Because see, like, waves, guys, you can say, like different waves are there, like, right? Correct. The waves which comes from oven, the waves which comes from your refrigerator, there are different waves are there. So every waves have different frequency and wavelength. Correct? Like, as we know that, guys, we have a different orbits, so every orbit have a different energies. So that's why whatever the waves are coming, every waves will have their own frequency and the own wavelength. So guys, what we know that every electromagnetic waves have various frequency or various wavelength. Okay, see, like this, guys, this is what they had given, this frequency of long radio waves, frequency of this radio waves, AM, FM, frequency of microwaves, frequency of infrared, frequency of this is what, this is the visible spectrum, the frequency of UV rays, X-rays, gamma rays. So all rays have a different frequency. If they have a different frequency, obviously they will have a different wavelength. I hope you understand this. So this is just for your understanding, so you can mark, so you'll understand the concept. Okay, now what will happen, guys? James Maxwell, that not Maxwell, Glenn Maxwell. Glenn Maxwell नहीं भाई, बहुत दिमाग खराब कर देता है Maxwell. If it is playing to RCB, it's fine, then we'll say ee sala cup namdo. But it will play, when India Australia will happen, when it will play from Australia, it will be like khatam, tata, bye bye. So that's why Maxwell, this is not the Maxwell, this is a different Maxwell. James Maxwell, what he did, James Maxwell was the first to give a comprehensive explanation about the interaction between charged bodies and behavior of electrical and magnetic field on microscopic level. Means what happened, guys? Maxwell was the first scientist. It gives the comprehensive explanation about what? It gives the comprehensive explanation about the, see, we know that, guys, previously also we studied that electric field will be there and then magnetic field will be there. Guys, we know one thing, that electric field and magnetic field are perpendicular to each other. Correct? Yes, sir. So we know that, guys, electric field is also present, magnetic field is also present. Both electric field and magnetic field are perpendicular to each other. And then what is happening, guys? We know that alpha particles are passing through it. So that's why here that we take it as a charged bodies. Here we have taken as a charged body. See, guys, this experiment. Here you know this. देखो इधर. किधर गया भैया? हाँ, guys, here. What is this? Blue color is this electric field, this blue yellow color, this electric field, and this is what north south pole is a magnetic field. So electric field and magnetic field are perpendicular to each other, and this is the ray, the particles, which is also perpendicular. And then what will happen? The interaction is happening here, correct? Because of that it will deflect to A point, C point. No deflection means it will go to B point, right? We learned. So that's why here in place of alpha particle, because we know alpha particle is also nothing but a charged particles. So here we have taken a charged particles. Okay, like proton, neutron, proton, neutron, positive charge or negative charge. Okay. So that's why what we learned here, guys, we have seen that James Maxwell was the first to give a comprehensive explanation about what? Interaction between charged bodies. Charged bodies means positive proton will go or negative electron will go with what? Behavior of electrical and magnetic field. Right, we know electrical and magnetic field. Every time, guys, keep in your mind electrical and magnetic field are perpendicular to each other. We already studied, so it will continue. Electrical and magnetic field are perpendicular to each other. In that, what will happen? The charged particles, either charged bodies, either electron or proton, will be interacting with that. So this concept of the electrical field present there, magnetic field present there, both are perpendicular to each other, and then the charged bodies, either electron or proton, are interacting with electrical and magnetic field. This concept is given by Maxwell. James Maxwell was the first to give a comprehensive explanation about the interaction between the charged bodies and behavior of electrical and magnetic field on macroscopic level, on a big level. It's not the small level, on a big level. He explained. Okay, what he suggested after explanation, he suggested that when electrically charged particle means, guys, electron or proton. So this electrically charged means we'll talk about electron. So he suggested when electrically charged particle moves under acceleration, so what will happen, guys? See, alternating electrical and magnetic field are produced and transmitted. Alternatively, electrical field and magnetic field will produce at a one same time. Electrical field, magnetic field, electrical field, magnetic field, electrical field, magnetic field not produce, guys. Alternatively, if electrical field is producing, only electrical field will produce. If magnetic field is producing, only magnetic field is producing. Okay, both field will be produced but not at the same time. So that's why they said alternating. Alternating means one after other. Alternating, either electrical field will produce, so whole electrical field will produce, or if what magnetic field is produced, so whole magnetic field is producing. Okay, so they said, he suggested that when electrically charged particle move under acceleration, so what is happening here? Alternatingly means either electrical field or magnetic field are produced and transmitted. It's not just produced. After producing, we have to transmit the electrical field also, or after producing, we have to transmit the magnetic field also. Okay, this concept, guys, already we studied before. There only just now I have shown you, right? Electrical field and magnetic field both should have to be there, then only the deflection and all will happen. So if no electrical field or magnetic field, it will go a straight line, point B. Okay, so electrical field and magnetic field, how we are going to place? Electrical field and magnetic field we will place on a perpendicular, to each other. Correct? First point you know. Correct? Second point, we know that at a time only one field will be produced. Either we will take electrical field, so only electrical field will be there, or we will take magnetic field to see if only magnetic field will be there. So only magnetic field will be there. Okay, both electrical and magnetic field will come to, if their strength will be equal, it will called a neutral, where the point will pass through a straight and hit to the point B, where the particle will pass through a straight line and hit to the point B, the previous experiment, right? Correct. So that's why they said this thing. He suggested that when electrically charged particle move under acceleration, alternatingly means either electrical field or magnetic field are produced. After producing, we have to transmit also. Why we have to transmit? Because it will flow in a wave form. The wave will transmit. So that's why we have to transmit. So these fields are transmitted, this field means this electrical field or magnetic field are transmitted in the form of waves called electromagnetic waves or electromagnetic radiation, because waves are nothing but radiation. Waves will follow, see, radiation will follow waves, means radiation will flow in the form of waves, so electromagnetic waves or electromagnetic radiation, because here we are using the both electrical field and magnetic field, so it's called as electromagnetic. Okay guys, this concept we have already studied before, that electrical field or magnetic field should have to be there, both, not only one at a time. If both will be there, then strength of electrical field and strength of magnetic field will become equal, it called electrically neutral, then the alpha particle will flow on a straight line, it will not show any deflection. So we want electrical field and magnetic field should be there. How it is being placed, bolo re pyare? Yes, electrical field and magnetic field being placed in a perpendicular to each other. Okay, and it will be only one, either electrical field will be using or magnetic field will be using, so that's why the word used as alternating. Okay, both we will not use at the same time. Now what they said next is, Maxwell was again the first to reveal that light waves are associated with oscillating electrical and magnetic character. Same thing guys. Again the waves are what? Associated with oscillating electrical and magnetic character. Same thing. As I said guys, again electrical field and magnetic field should have to be there. If electrical field and magnetic field is there, then babu bhaiya, then only it will show the electric and magnetic character. If electrical field is not there, no electric character. If magnetic field is not there, no magnetic character. Okay, so electrical field and magnetic field should have to be there. First point, understand guys, these few points you have to keep in your mind. First point is what? Electrical field and magnetic field should have to be there first. Second point is, both electrical field and magnetic field should have to be placed perpendicular to each other, correct? Third is what? We are using alternating, either electrical field we will use at a time or magnetic field we will use at a time, both we will not use at the same time. Okay, this point you have to keep in your mind. If electrical field is there, then it will show electric character. If magnetic field is there, then it will show magnetic character. So that's why we are using both electrical and magnetic, so it's called electromagnetic. The radiation will flow in the form of wave, so we can say electromagnetic wave or electromagnetic radiation. Okay, this is the same thing guys. Electric and magnetic field component of electromagnetic wave, like this. Red color is what? See this. This is the electric field, okay, and this is the magnetic field. Electric field is coming like this, magnetic field is going like this, 90 degree, it should be perpendicular, it is coming like this, it is going like this. Okay, see. So what they said, these components have the same wavelength, frequency, speed and amplitude, but they vibrate in two mutually perpendicular plane. Again guys, perpendicular plane, keep in your mind. Now this is what? This is the electromagnetic wave properties. If they will ask about the Maxwell, what did the Maxwell did guys, you have to tell this thing about the Maxwell. Okay, now here guys, if they will ask you about write the electromagnetic wave properties, see babu bhaiya log, are oh pyare, don't become chacha chautin and start learning this structure, it's not there. Just you have to understand from here that vibrate in two mutually perpendicular planes, that's it. Ashte guys, ashte. Okay, now electromagnetic wave properties, they will ask you to write the properties of electromagnetic waves. So this is the properties guys. If you read now, you will understand that I have explained everything. See, oscillating electrical and magnetic field produced by oscillating charge is what? Very important is this, are perpendicular to each other, and both are perpendicular to the direction of propagation of wave. So propagation of wave direction is like this. So electrical field and magnetic field should have to be perpendicular to each other, and they should have to be perpendicular to the direction of propagation of wave. Okay, because this already we studied here. अरे देखो रे प्यारे, देखो बाबू भैया लोग. See here, electrical field and magnetic field should have to be perpendicular to each other, and they have to be perpendicular to these particles. Correct, we already studied the same thing they said here. Okay, So first thing what we get to know, electrical field and magnetic field are perpendicular to each other and both are perpendicular to the direction of propagation of wave, because we know that radiation will flow in the form of wave. So that's why direction of propagation of wave. Second thing is what, see, electromagnetic wave do not require medium and can move in vacuum. So guys, electromagnetic wave now, it does not require any medium to travel. It will travel in a vacuum. Vacuum means what? Empty space. Okay. Now this is what, this is the simple thing we know guys. See, there are many types of electromagnetic radiation. We know guys, just now we saw radio waves, microwaves, infrared, UV rays, X-rays, gammas, right? So that's why there are many types of electromagnetic radiation, right? There are many types of electromagnetic radiation which differ from one another in wavelength of frequency. Just we learn guys, there are many electromagnetic radiations. There are many electromagnetic radiations, and each electromagnetic radiations have different frequencies and different wavelength. Obviously just now I explained, correct? So these constitute what is called electromagnetic spectrum. Electromagnetic spectrum. Spectrum is nothing but guys, we have a different radiations which is having its own this frequency band or wavelength band. So what is called, that's called electromagnetic spectrum. In see in the rainbow you study the spectrum of light, correct? Spectrum of light in rainbow, wave gear. So different light have different frequency and wavelength, correct? The same like that. Here we are talking about electromagnetic wave and electrical wave and magnetic wave. So that's why we call it electromagnetic and the same spectrum, because every radiation is having its own different frequency and wavelength. So yeah, it have a different frequency and wavelength, so that's called as a spectrum. So it will be an electromagnetic spectrum. Okay, so this is done. Now guys, see, this part is not just for your understanding. Like see, radio frequency region, if we'll talk about radio frequency region, so it have a different frequency, and where it is used for broadcasting. If you will see the microwave, sorry guys, this is a different frequency. If you'll see the microwave region, so it have a different frequency used for radar. Infrared region, different frequency used for heating. Ultraviolet region have a different frequency, a component of sun's radiation, because UV will come from suns. Then a small portion around different frequency is what is ordinarily visible, so it's called as visible light. See guys, these all now see, this long wave, radio wave, microwave, infrared, UV, X-rays, gamma rays, means what I can say, it cannot be possible to seen by naked eyes, but these portion, that's called visible spectrum. These portion, that's called visible spectrum. That is the visible spectrum is visible by our naked eyes. So this is what, this is the visible spectrum which is visible by our naked eyes. So they say the small portion around this much of hertz is what is ordinarily called visible light, because why, it can be visible by naked eyes. So see, it is only this part which our eyes can see, the visible light. Okay, then what they said, a special instrument are required to detect non-visible radiation. So there are two types of radiation. First is visible radiation, non-visible radiation. Visible radiation are those radiation, these are the visible radiation which we can able to see with our naked eyes. But these are the invisible radiation. So these are the invisible radiation, or you can say non-visible radiation, which we cannot able to see by our naked eyes. So what we will do, we will use a special instrument to detect that. Okay, yes sir. Next is the third point guys. The fourth point, you will write this: different kind of unit are used to represent electromagnetic radiation. Obviously guys, different wavelength. See, the electromagnetic radiation have a different electromagnetic radiation. There are many electromagnetic radiations. Each electromagnetic radiation have a different frequency. Each electromagnetic radiation have a different wavelength. so they have a different kind of units. Okay, I hope till here you understand, guys. Okay, ठीक है, done. So now whatever we are learning, guys, we are learning that we have a not only one electromagnetic waves, we have a different electromagnetic waves. First, if different electromagnetic waves have a different frequency, they have a different frequency means they have a different wavelength, they have a different wavelength means they have a different kind of units. So everything have a different, it's not a similar for all the electromagnetic waves. If it is a different electromagnetic waves, all the things will be different, different frequency, different wavelength, different units. Okay, so what will happen, see, these radiations are characterized by their properties, what, frequency and wavelength. The two important thing we are going to divide is based upon the frequency and wavelength. Okay, so guys, this is the definition of frequency. SI unit of frequency, see, frequency is denoted like this, nu, and SI unit of frequency is hertz. It is given by the scientist Henrik Hertz. And what is the definition of frequency? It is defined as number of waves that pass a given point in 1 second. That's called frequency. Correct. Wavelength, guys, unit is meter. Wavelength is what, denoted by lambda. Wavelength is what, guys? अरे बोलो रे प्यारे, wavelength भैया, अरे देखो जी, wavelength is denoted by lambda. This is called as lambda. Lambda. This is the wavelength. SI unit is meter. Okay, okay, now see here, guys, in vacuum, we know, guys, electromagnetic wave does not require any medium to flow, it travels in vacuum. So in vacuum, what will happen, all types of electromagnetic radiation travels with the same speed, that is 3 into 10 to power of 8 meter per second. Okay, so guys, what we know that electromagnetic radiation does not require any medium to travel, it travels in vacuum. So if it is traveling in vacuum, guys, obviously if anything is traveling, we want its speed. Correct, if anything is traveling, we want its speed. So guys, what is the speed of wavelength, sorry, speed of electromagnetic radiation? The speed of electromagnetic radiation is nothing but we will take the speed of light, 3 into 10 to power of 8 meter per second. If in examination they will ask the speed of wavelength of light, sorry, speed of wavelength of electromagnetic radiation or electromagnetic wave, directly we will write 3 into 10 to power of 8 meter per second, that is nothing but the equal to the speed of light. Okay, this is the Bohr's model, this is for understanding. This is about the Maxwell, and this is the definition of electromagnetic waves or electromagnetic radiation. From here only you will write the definition of electromagnetic waves and electromagnetic radiation. This is just for understanding, this is also for understanding. This is what you will underline is for electromagnetic wave properties if they will ask. Then the pink color, which is underlined, the first point, second point, third point, fourth point, these are the electromagnetic wave properties, pink color. This blue color is just for your understanding. Okay, like every, what you will say, every electromagnetic waves have a different frequencies and different wavelength. So based upon that we can do the two things, either it is visible to our naked eyes or it is non-visible to our naked eyes. Visible to our naked eyes, we call it as a visible region. This visible region, we can see the different colors. If it is non-visible to our naked eyes, then we will use a special instrument to detect it. So this is just for your understanding and mark it, guys. If they will ask in 1 marks, you can write. Okay, this is the thing, like radiations, the electromagnetic radiations will mostly focus for their wavelength and frequency. Okay, so this is the definition of frequency, units of frequency, this is the units of wavelength. Okay, and here, guys, if they will ask the speed of electromagnetic radiation or speed of electromagnetic wave, we know that electromagnetic radiation, electromagnetic wave क्या होता है भैया, it does not require any medium to flow, it flow in a vacuum also, but anything is flowing or anything is traveling, guys, we require the speed. So electromagnetic radiation ka speed is what? Yes, exactly equal to speed of light, that is 3 into 10 to power of 8 meter per second. That is nothing but speed of light given by symbol c. Okay, Now this is a important, guys. Many times, by using this formula, many times they asked in the examination this formula also. By using this formula we find the like numericals. We did the numericals also. So what is this formula, guys? C, we know speed of light, this nu is the frequency, and this is lambda. So this relation is what? This relation is nothing but frequency, wavelength, and velocity of light, guys. Velocity nothing but speed. Okay, because 3 into 10 to the power of 8 meter per second is nothing but speed of light. So see, this is what? This is the relationship between, not yours. This is the relationship of frequency, wavelength, and speed of light. So guys, the relationship between the frequency, wavelength, and speed of light is C is equals to nu into lambda. So guys, what will happen in examination? They will give this frequency. Okay, and we know speed of light will remain fixed. It is not going to change. 3 into 10 to the power of 8 meter per second. This will be fixed. So what will happen in examination? If suppose frequency, they will give, you have to find lambda. So how we will write the formula? We know frequency will go this side, so it will become lambda is equals to C by frequency. Correct? Or second option, what will happen, guys? They will give the lambda, you have to find the frequency. So what will happen? Frequency is equals to C by lambda, because lambda will go this side. Correct? C value will remain same, 3 into 10 to the power of 8. Khatam. So this is the relationship between speed of light, frequency, and wavelength. Ashte guys, ashte. Okay, this is. Now see, in the examination, you have to know, because in examination they will ask this question is which of the, see they ask the question is, kaun sa question pucha hai? See, with the help of this, now what I'm going to tell you, with the help of this, they did this also. What else? Even in the KCET, even in the NEET also, they asked the question. Based upon this, they asked the question, guys. Okay, see how they ask now. They ask the question is which of the following rays have a highest frequency, or which of the following rays is having lowest wavelength, or highest wave frequency, or highest wavelength. They will ask like this. Okay, so you have to remember like this. Okay, see, you have to write. I'll give you one trick. रेडियो में radio may means what, like like it will play an FM radio and all. Okay, so in that radio में what, radio में I means मैं, radio में I वचन देता हूँ. Okay, रेडियो में I वचन देता हूँ. You keep as like a वचन देता हूँ ex girlfriend से चैट नहीं करूँगा. ओके, व्हाट इज दैट? ऐसी रेडियो में आई वचन देता हूँ एक्स गर्लफ्रेंड से चैट नहीं करूँगा. Okay, remember like that, guys. Okay, what is it? रेडियो में आई वचन देता हूँ. रेडियो में आई वचन देता हूँ. Who means HUN. तो that who I am using. Okay, रेडियो में आई वचन देता हूँ एक्स गर्लफ्रेंड से चैट नहीं करूँगा. ओके, बिकॉज तो सी व्हाट विल हैपन ना, इफ यू विल गो लाइक दिस मीन्स व्हाट इज हैपनिंग, frequency increases. Guys, we know frequency and wavelength are inversely proportional. You can see from here. Okay, see, this is what wavelength, this is frequency, inversely proportional, right? This is the frequency, this is the wavelength, so inversely proportional. Okay, so what is this? Wavelength and frequency are inversely proportional. frequency and wavelength both are inversely proportional to each other. Means guys, see, if this side you are moving, the frequency is increasing. So what I will say, lambda means what? Wavelength is decreasing. Correct? If I am moving this side, so this side means what will happen? Frequency decreases. If frequency decreases, then wavelength increases, because frequency and wavelength are inversely proportional to each other. ठीक है, अब नाम लिखेंगे guys. See, radio mean this is, see, this is what? This is a radio wave. Radio na, radio. So this is a radio wave. रेडियो में मैं वचन देता हूं, रेडियो में दिस इज व्हाट? रेडियो एम मीन्स माइक्रो, दिस इज अ माइक्रोवेव. ओके, रेडियो वेव, रेडियो में मीन्स माइक्रोवेव, रेडियो में आई मीन्स व्हाट? इंफ्रारेड, आई मीन्स इंफ्रारेड. ओके, रेडियो में आई वचन, वी मीन्स विजिबल, वी मीन्स विजिबल. रेडियो में आई वचन देता हूं, यू मीन्स यूवी, यूवी रेस. ओके, रेडियो में आई वचन देता हूं, एक्स मीन्स एक्सरे, एक्स मीन्स व्हाट गाइस? एक्सरे. एक्स गर्लफ्रेंड, जी मीन्स गामा. एक्स गर्लफ्रेंड, एक्स गर्लफ्रेंड से चैट नहीं करूंगा, सी मीन्स कॉस्मिक. हाँ, कॉस्मिक. ओके, दिस इज द ट्रिक यू हैव टू रिमेंबर गाइस. रेडियो में आई वचन देता हूं, एक्स गर्लफ्रेंड से चैट नहीं करूंगा. ओके, दिस R is a radio wave, M is a micro, I is the infrared, V is the visible, U is the ultraviolet, X is the X-ray, gamma ray, cosmic. Okay. Now suppose if they will ask this thing is, which of the following is having the highest frequency? So this side if you are going, frequency is increasing. The cosmic rays is having highest frequency. So highest frequency means lowest wavelength, because frequency and wavelength are inversely proportional to each other. Here guys, what will happen? They will ask which of the following is having the highest wavelength. So this R, radio waves, is having the highest wavelength to lowest frequency. Or suppose they will give any four, like suppose they will give R, I, U, C. They will give four and they will ask you that arrange them in increasing frequency order. Increasing means small to big. So which is small? R, then I is greater than R, then U, then C, like this. Okay, so like this they will tell you to arrange in increasing frequency order, or arrange in decreasing frequency order, or arrange in increasing wavelength order, or arrange in decreasing wavelength order, or they will ask which of the following is having the highest frequency. Okay, or which of the following is having the lowest frequency or highest wavelength, lowest wavelength. Okay, suppose they will give this much, these three, and they will ask you that which of the following is having highest frequency. The highest frequency means this side you will go, frequency will increase, so U. Lowest wavelength, U. Highest wavelength, R. Like that. Okay, if you know this, that's khatam. Okay. Now guys, see, this is a definition of wave number. Wave number is denoted by this. देखो रे प्यारे, wave number is denoted by this. Frequency upon that will put the bar, not that bar. Frequency upon this bar, so that is called as wave number. Wave number. Okay, so babu bhaiya log, this is the definition of wave number. Wave number is what? Is defined as the number of wavelength per unit length. Okay, wave number is what? Defined as the number of wave number, not number of wavelength per unit length. Okay, its unit are reciprocal of wavelength. See, formula of wave number, na guys, you want you can write this. No, you have to write. See, wave number formula is what? 1 by wavelength. Wave number formula is 1 by wavelength. So guys, see, unit is what? 1 by wavelength means what? 1 by wavelength unit is what? Bolo re pyare, M. So if you will do ulta, it will become M minus 1. Correct? Ulta means what? It will go up reciprocal. So M power minus 1. So wavelength SI unit is, see, wavelength SI unit is meter. Wave number is what? Wave number is reciprocal of wavelength. Wave number is what? reciprocal of wavelength. So its unit is 1 by m. If nothing but m will go up, it will become m minus 1. Correct? Yes, sir. That's done. Now let's solve the problems, not yours. Okay. So guys, see here. Okay, this is not, this is the this they will ask the relation, so you have to write this, or we have to use this for solving the problems. Okay. Okay, this is what, here you will write the definition of wave number. Okay, तो देखो भैया, अरे आ जाओ जी प्यारे. Okay, now see problem 2.3 guys. They said the Vividi Bharati station of All India Radio Delhi broadcast on frequency of this, guys, frequency they had given, okay, ठीक है. Calculate the wavelength of electromagnetic radiation emitted by transmitter. The first thing guys, what we have to find? Wavelength. अरे ओ प्यारा देखो जी, wavelength means what guys? Lambda. Lambda is equals to c by frequency. Correct? Well, lambda is equals to c by frequency. We will use this formula because we have to find the wavelength. We have to find the wavelength and frequency is given. So c we know, it will remain same, 3 into 10 to power of 8. See, they had given the frequency of this much. The frequency is given re pyare. What we have to calculate? Calculate the wavelength of electromagnetic radiation emitted by transmitter. So we have to find the wavelength. The wavelength is what? This lambda is equal to c by mu. Okay. So बाबू भैया लोग, c is 3 into 10 to power of 8 meter per second. We know mu is given 1368 kilohertz. Guys, so we know that it's SI unit is not the kilohertz. We have to keep in hertz. So what we will do? Into 10 to power of 3, it will convert it into hertz. The frequency will convert it into hertz. Okay. Now देखो रे प्यारे, just we will use the calculator and we will get the answer. And guys, what they said, which part of electromagnetic spectrum does it belongs to? Which part? See, they are talking about All India Radio. So All India Radio means what? This is the characteristics radio wavelength. Radio wave, because they are talking about radio. From radio wave is coming. Ashte guys, ashte. Okay, and how to solve this guys? I know how, you know how to solve this. Divide this to, okay, whatever you are getting right here into 10 to power of 8 minus 3, 10 to power of 5. Means after that what you will do? Just the sign notation and all you will use, you will get this answer. Correct? Yes sir. So problem 2.3 is done and I hope it is crystal clear. Are oh pyare bolo ji. Yes sir. Now 2.4 guys, see 2.4 easily you can do, easy peasy guys. See, they said that wavelength, they are talking about wavelength range of visible spectrum extend from violet. So see, wavelength of violet light is given to red, means what? Wavelength of violet light is given 400 nanometer. Nm means what? Nanometer. And then wavelength of red light is given 750 nanometer. What they said, express these wavelength in frequency. We have to write in terms of frequency. Are oh pyare dekho na ji, frequency is what? Speed of light by wavelength. Khatam. So guys, they have given 1 nanometer is nothing but 10 to power of 9 meter, 10 to power of minus 9 meter. Sorry guys, 10 to power of minus 9 meter. So what we will do re pyare dekho, C value will remain same, 3 into 10 to power of 8 meter per second. So guys, they had given the wavelength of violet and wavelength of red. So we have to express these wavelength into frequency means what? Yes guys, first we have to find the frequency of which color? Violet color. Then what we have to do? Then we have to find the frequency of what? Frequency of red color, because two color wavelength is given, violet color wavelength is given. So for violet color wavelength I will find the violet color frequency. Then guys, what? Red color wavelength is given. If red color wavelength is given, from red color of wavelength I will find the red color frequency. Correct? So whoever wavelength is given, we will find its frequency. How we will find? C by lambda. C value will remain same. Lambda value we have to substitute. It is 400 nm and 1 nm is 10 to power of minus 9. So it will become 400 nm. 400 nm. So it will become 400 into nm is what? 1 nm is 10 to power of minus 9 meter into 10 to power of minus 9. See here. So what we will do guys, in the calc we will take out the calculator. and you will just do this part. So 3.0 divided by 400, you are getting you are getting 0.0075, and this is what guys, देखो अरे ओ प्यारा देखो जी, into 10 to power of 8, and see into what will happen, this 10 to power of minus 9 will go up, so minus 9 will go up, it will become plus 9. So 10 to power of 8 into 10 to power of 9, guys, in Chuttu class you have studied when see, when bases are same, and it is multiply, so power will get add. You know this, guys. What we know, if bases are same and see here, bases are same and it is multiply, तो बोलो रे प्यारे, power will get add. 10 plus 9 it is 7, sorry 8 plus 9 is 17, so you will get into 10 to power of 17. Okay, frequency means hertz. If you want to write this much also, guys, this is also correct, but if you do want to do a scientific notation, then what will happen, it will come this side, 1 2 3, so it will become 7.5 into 10 to power of, see, we are moving from here till here, means we are moving to a right side means minus, so 10 to power of 17 minus how many digits we moved, 1 2 3 digits, so 10 to power of minus 3, it will become 7.5 into 10 to power of 17 minus 3 is 14 hertz. See the answer. Khatam. Okay, now the same thing as you have to find the frequency of what? Yes, frequency of red light. So pause it and just check the answer, guys, what you are getting, the frequency of wave white light is same or not. Sorry, frequency of red light. See, frequency of red light, when you will do, you will get this. That's it, khatam. So range is what? Range is from 4 to what is here, 4 to 7.5. That's it. See, 4.00 into 10 to the power of 14 to 7.5 into 10 to the power of 14 hertz. Khatam. Okay, see, they said calculate the wave number. Wave number का formula बोलो रे प्यारे. See, wave number is what? 1 by wavelength. Just we learn. And frequency. Frequency formula is what? Frequency formula is, oh sorry guys, this is not the bar. Frequency is C by lambda. Frequency is what? C by lambda. So see, they had given the calculate the wave number and frequency of yellow radiation having wavelength. So wow bhai yellow wavelength it is given. Okay, this is angstrom. The wavelength is given. Dekho, what will happen, guys? Will convert into meter. So 1 angstrom is nothing but 10 to power of minus 10 meter. 1 angstrom is nothing but 10 to power of minus 10 meter. So 5800 angstrom means what? 5800 into 10 to power of minus 10 meter. So see, 1 by lambda. So this. So how we will solve this, guys? How we will solve this? Very simple. Just divide this. 1 divided by 5800. 1 divided by 5800. You will get 0.000172, that much, right? 0.000174 into, see, 10 to power of minus 10. When it will go up, it will become 10 to power of 10. So what will happen? We'll do the scientific notation. 1 2 3 4, so it will become 1.724, going to right side means here minus 4, so it will become 1.724 into 10 to power of 6. See, 6 per meter. Khatam. Okay, now next is what? Frequency. C will remain same. Lambda, we get to know this. Sorry guys, lambda is this, so we'll use the lambda, we will get the answer. Simple. Now guys, we will come for the next part. We will see is next part we will see is this particle nature of electromagnetic radiation. Now we have seen the wave nature. See guys, till here what we learned here is wave nature of electromagnetic radiation. Wave nature of electromagnetic radiation is done, where we will be using the electromagnetic wave and electromagnetic wave means electrical magnetic field and electrical field and magnetic field, that's called as electromagnetic wave. So guys, I hope you understand this concept till here, and we did the numericals also, and I had told you how to remember that naming also. Okay. Now from here guys, it is very easy peasy. Just you have to understand the concept. Okay, understanding the concept is what very simple thing. See here. Now see, देखो बाबू ये लोग पानी वानी पीते रहो भाई, पानी वानी पीते रहो, 1 hour हो गया, पानी से पीते रहो. Now guys, wave nature is done. Now we will see the particle nature of electromagnetic radiation. देखो रे प्यारे, particle nature of electromagnetic radiation is explained by whom? Planck's quantum theory. Planck was the one scientist. Okay, he explained about this particle nature of electromagnetic radiation. So particle nature of electromagnetic radiation is explained by Planck's quantum theory. Okay, so देखो, first we have to see that what are the drawbacks. Drawbacks of what? Drawbacks of our wave nature of electromagnetic radiation. So guys, this is see some of the observation which could not be explained with the help of even the electromagnetic theory, means wave nature. What are this? These are these. First thing is what? Black body radiation. Black body radiation cannot able to explain. So what will happen? Black body radiation. Black body radiation means we have a body which is of color black and it will emit the radiation. So that's why what in the black body radiation, what we cannot able to explain, the nature of emission of radiation from hot bodies. Okay, nature of emission of radiation means, you know, the radiation will emit. So what is the nature of the emission of radiation? So see, from hot bodies, guys, hot bodies is nothing but we can call it as a black body also. Okay, because when it will become, you know, hot, we call it as a black body. Okay, so don't get confused with the black body and hot bodies. No, if we'll give the temperature, the normal body will absorb the temperature. That normal body will become a heated object. So that hot bodies, heated object means what? Hot body is also called as black body. Okay, so black body radiation, first they cannot able to explain. So what is the black body radiation? In that, what they cannot able to explain, the first point is nature of emission of radiation, means whatever the radiation are emitted, its nature. Okay, next is what? Photoelectric effect. Guys, photoelectric effect means we will learn about that. So in that, what will happen? See, photoelectric, I will tell you a small thing. I will take this as a metal surface. What is this? Metal surface. In metal surface, I will hit the light ray. What I will do? I will hit the light ray. So light ray means what? That's called photo. Like, you know, photosynthesis, right? With the help of light, sunlight. Yes, that's why photo means what? Light. If I will take, see, black body radiation is what? I will take a normal body. In that, I will give the heat to the normal body. So what will happen? When the normal body will get the heat, the normal body will absorb the heat, right? When normal body will absorb the heat, this will called as hot object or heated object. So once it will absorb the heat, what it will become? It will become heated object. Then this heated object will start releasing the radiation. Okay, so heated object is called as black body and they are releasing the radiation, that's called black body radiation. Why black body? We will say the normal thing, we know that normally like black color will absorb, the good absorber of heat is black, correct? That's why it's called black body radiation. Okay, so that's why hot body is called as black body, because the black body is a good absorber of heat. Okay, so that's why it will emit the radiation properly. Second is what, guys? Photoelectric effect. Photoelectric effect means what will happen in the photoelectric effect? देखो रे प्यारे, कौन कर रहा जी काम जी? Okay, photoelectric effect means what will happen? Now guys, see, I will take any material. I will take any material. I will take any metal, not any material, metal plate. I will take as a metal plate. In that metal plate, I will hit the ray of light. What I will do? I will release the ray of light. I will release the ray of light. So that's called photo. Photo means what? In the metal plate, upon the metal plate I will hit the ray of light. As the ray of light will hit on the metal plate, what will happen? बोलो रे प्यारे, the metal plate will start releasing the electron. Okay, if we will hit the ray of light in the metal plate, the metal plate will start releasing the electron. Electron means what? Electron means what? Charge. The charge means what? Electric. So that's why photoelectric effect. Photoelectric effect means I will take a metal plate, in that I will hit with a ray of light, and with that ray of light the electrons particle will come out. So that's why it's called as photoelectric effect. So what will happen? Ejection of electrons from metal surface when radiation strikes it. Same thing I explained. Radiation is nothing but light radiation. Okay, ray of light. Next is what? Variation of heat capacity. Variation of heat capacity of solid as a function of temperature. So in the solid body, the variation of the heat capacity as a function of temperature, it cannot able to explain. This is not we are going to study in the depth. Just the name is means this much is enough. You have to write. Okay, these two we have to study in the depth: black body radiation and photoelectric effect. So let's see, guys. Chalo. And the fourth one is line spectra of atom with special reference to hydrogen. Line spectra of atoms, what we will learn in the upcoming topic, that is spectral line. You know, Lymer, Balman, Paschen. Okay, this one. This is a line spectral. Okay. Okay, so these are the 4 points done. Now next is, guys, this just we have to read and we have to understand. Okay, this green point: intensity of radiation of different wavelength emitted by hot object depend upon its temperature. We know, guys, see, intensity, this is the hot, suppose this is a hot body. Okay, hot body. What the hot body will release? Wavelength emitted. See here, hot body will release the radiation. Okay, suppose two things will happen, guys. If it is not very hot, if it is not very hot, so the intensity of radiation is also not high. If another, suppose I will take a two object, object A and object B. If object A, the heat of this object, means whatever we have given the heat to this object, the heat of this object is not so high. So what will happen? If the heat of this object is not so high, then the radiation will come out is also low. Another is what? I will take the object which is highly heated. I will take the like another object, I will take it as a highly heated. So if it is a more heated, means the intensity of radiation coming out is of high intensity. Correct? So guys, intensity of radiation in the object B, which is more heated, the intensity is very high because it is more heated. The more heated means intensity of radiation coming out is very high. And the object A, in which the it is not heated very high, it is not heated very high. If it is not heated very high, so the intensity of radiation coming out from here is not very high. Okay, it is what? It is of less intensity. So that's why high intensity, less intensity depends upon what? Depends upon temperature. So that's why it says that intensity of radiation of different wavelength from where? Emitted by hot object depends upon its temperature. If I am giving the low temperature to this object, it will get less heated. As it will get less heated, the intensity of radiation coming is less intensity. Okay, if this is the object, I will give a high temperature. High temperature means what? This object will get highly heated. If it is getting highly heated, means what? Intensity of radiation is also high. So that's why they said intensity of radiation of different wavelength emitted by hot object depend upon its temperature. So see, object made up of different material, guys, we know object made up of different material and kept at different temperature emit different amount of radiation, correct? Guys, see, every object does not made up of same material. So what we know, that object is made up of different materials. So if object is made up of different materials, so they are kept at different temperature, correct? And if it is keeping at different temperature, so it will emit the different amount of radiation, right? This is important. This pink color and yellow color is important. This pink color is what? Ideal gas. And ideal gas means perfect, sorry, ideal body. Sorry guys, sorry. Ideal body. Ideal body is nothing but a perfect body. So an ideal body which emits and absorb radiation of all frequency is called black body. Because what, guys, we know which color will absorb all radiation? Black color, right? We know that which color will absorb all radiation? Black color. Okay, so black color is called as ideal body to absorb all colors. Okay, so that's why they said an ideal body, perfect body which emits and absorbs radiation of all frequency is called a black body. And the radiation emitted by such a body is called black body radiation. Okay, we know that black body means what? Black object is an ideal object which absorb and emit what? Radiation of all frequency. So ideal object means a perfect body which emits and absorbs radiation of all frequency is called black body, and the radiation emitted by such a body is called black body radiation. Correct? Yes sir. But in real what, guys? In practice, no such body exists. Means no such body exists means what? No such ideal body exists. Because we know, guys, in real there is a no 100%. So in practice, like in real, no such ideal body exists. But in examination, many times they ask the question. So you have to write the carbon black. Carbon black approximate fairly close to black body. In examination, if they will ask what is black body, so we will write this: an ideal body which emits and absorbs radiation of all frequency is called black body, and the radiation emitted by a black body is called black body radiation. Okay, next they will ask, is there all body like a perfect ideal body like that? So we will say that no, there is no such ideal body exist. But if they will ask the example of ideal body, then you have to write a carbon black which is fairly closely to black body. It's not a perfect black body, which is fairly closely to black body. Okay, example, you have to write a carbon black. Okay, now guys, see here, we know that what it will, a black body, what it will absorb. Black body will absorb the heat from the surrounding. Correct? Okay. What will happen, guys? A black body will absorb heat from its surrounding. Okay. And then black body will emit the heat to the surrounding. Correct? So what will happen? A black body is absorbing the heat from the surrounding, correct? And black body is releasing the heat to the surrounding, correct? Because see, if you'll give the temperature, so what is happening? This black body, if you'll give the temperature, what is happening? This black body will absorb the heat. So from where it is absorbing the heat? It is absorbing the heat from the surrounding. Means I am giving the temperature, so from the surrounding. And then same black body is releasing the heat to where? Black body is releasing the heat to the surrounding. So what is happening? The black body is absorbing the heat from the surrounding and black body is releasing the heat to the surrounding. So that's why releasing heat, gaining heat is what? It's called a thermal, because heat is what? Called thermal. The very important thing you have to keep in your mind is, oh bhaiya dekho ji, suppose this is a black body. Okay. So guys, how much heat it will absorb? From where it is absorbing the heat? It is absorbing the heat from the surrounding. Okay, suppose this is the black body. चलो भैया black body will draw with black only guys. देखो इधर, this is a black body, this is a black body. Okay, so what is happening guys, this is the black body. So black body, how much amount of heat absorbed by the black body from the surrounding? Okay, this is what, this is a black body. So how much amount of heat absorb, how much amount of heat absorbed by the black body from surrounding, the same that much of heat it will release to the surrounding, because it is a perfectly black body, na ideal black body. So ideal black body, what it will do, how much heat absorbed from the surrounding, that much heat released to the surrounding. So what is happening guys, we are talking about heat. Heat means what, heat is called as thermal, correct? And see how much heat it is absorbing. देखो भैया इधर, how much the quantity of heat it is absorbing from the surrounding, that much quantity of heat it is releasing to the surrounding. Means what, how much it is taking, that much it is releasing. Means what, that word is called as equilibrium. What is equilibrium guys, how much it is taking, that much it is releasing. So means what, it is in equal condition. So equal condition means in chemistry we will say equilibrium. So I hope you understand the meaning of thermal equilibrium. Thermal equilibrium means any black body is there which will absorb the heat from the surrounding, and how much quantity of heat it is absorbing from the surrounding, the same quantity of heat it is releasing to the surrounding. So means that's called thermal equilibrium. Okay, yes sir. So that's why see, a black body is in thermal equilibrium. Why it is in thermal equilibrium? Because sir, black body is in thermal equilibrium. Now the reason is how much heat is absorbing from the surrounding, the black body, that much heat is releasing to the surrounding. So it is in equilibrium, and we are talking about heat, so it's called thermal equilibrium. So a black body is in thermal equilibrium with its surrounding, correct? With its surrounding means what, suppose it is it is gaining the heat of 40. So what is happening, heat is absorbing the heat from the surrounding at 40, so it will releasing the heat to the surrounding at 40. So what is the unit is same, so it's a equilibrium condition. We are talking about heat to thermal equilibrium. Okay, a black body is in thermal equilibrium with its surroundings. Okay, a black body is in thermal equilibrium with its surrounding. Means what, it radiates the same amount of energy per unit area as it absorbs from its surrounding in given time. The same thing, how much it absorbs from the surrounding, same amount of energy is released to the surrounding. Khatam. Okay, now guys, this is the thing, just read it out. This is the thing, just we have to read it out. देख लो भैया. See the amount of light emitted from a black body. See, amount of light emitted means what, intensity of radiation, correct? See, amount of light is emitting means what, radiation, correct? Amount of light is emitting, so it's like a radiation form. And intensity means what, how much amount is releasing, correct? That's called intensity. If less amount is releasing, I will say less intensity, correct? If high amount is releasing, I will say high intensity. Okay, if you are studying with less amount, I will say you are showing less intensity. If you are if you are studying with a higher amount of your energy, I will say high intensity, correct? ठीक है देयर. Amount of energy emitted means nothing but intensity of radiation, because here everything we are talking about radiation. Either it is emitting to radiation, either it is absorbing to radiation. So amount indicates the intensity. High amount means more intensity, less amount means low intensity. So amount of light emitted from a black body and its spectral distribution depends only on its temperature. Just now we learned guys, everything depends upon temperature. At a given temperature, intensity of radiation emitted increases with increase of wavelength. So what we learn guys, at a given temperature, some temperature is there, so intensity of radiation emitted, how it will increases with increase of wavelength. and then reaches the maximum value and then starts decreasing with further increase of wavelength. Okay, so guys, understand very important thing. At a given temperature, see this is what they're talking. This is a wavelength, this is a intensity. So at a given temperature, suppose I kept the temperature as T1. So at a given temperature, what is saying? See here, with increase in wavelength, the intensity will increase and reaches to the maximum and then it starts decreasing. Okay, see here, at a given temperature, I kept the temperature as T2. So what is happening? The intensity with increase in wavelength, intensity is increasing and reaches to the maximum. Then again it decreases down. The same thing they said. See here. At a given temperature means what? Suppose I will keep this T2 as a given temperature means what? Temperature is T2. At a given temperature, what is happening? Sorry. At a given temperature, what is happening, guys? See, at a given temperature, intensity of radiation increases. Intensity of radiation increases here. This is intensity. The intensity of radiation increases with increase of wavelength. See, intensity of radiation increases with increase of wavelength, because see, you can see here, guys, wavelength is increasing. Okay, wavelength is increasing, correct? So with increase in wavelength, what is happening? Intensity of radiation increases. See, at a given temperature, what is happening? Intensity of radiation increases. So at a given temperature, suppose I will keep the temperature as T2. So what will happen? Intensity of radiation increases with increase in wavelength, reaches a maximum value. See, reaches a maximum value. This is the maximum value, and starts decreasing. See, and starts decreasing with further increase of wavelength. Understand? This is only the thing they said. Okay. This is what the wavelength intensity relationship. If they will ask in the examination, wavelength intensity relationship means, keep in your mind, guys, we have to keep a given temperature. Temperature will remain constant. We are not going to change the temperature. So that's why we said at a given temperature, means temperature remains constant. So at a given temperature, you can see here, what is the temperature? If I am talking about this temperature is same T1. So at a given temperature, what is happening? Intensity of radiation increases with increase in wavelength and it reaches to maximum, then it starts decreasing with same increase in wavelength. Correct? Yes, sir. This is the wavelength intensity relationship, not yours. See, you have to study every relationship except yours. Jindagi kharab ho gaya. Okay, now guys, here we have to learn about the thing is, atoms and molecules could emit or absorb energy. It is possible, like, atoms and molecules also could emit or absorb energy, right? Only in discrete quantities. See, very important thing. यहाँ पे important चीज आया जी. अरे भैया, अरे ओ प्यारे समझो जी. देखो इधर. What they said, guys. Atoms and molecules could emit or absorb energy only in discrete quantities and not in continuous manner. Means, if suppose atoms and molecules are absorbing or releasing energy, they will release in discrete quantity, means what you can say, not continuous. Okay, what they said, guys, atoms or molecules, they also can see, atoms and molecules also have some feelings now. So atoms and molecules could also emit or absorb energy. They also could absorb or emit energy. But if atoms or molecules will, absorb or emit energy, it will be not in a continuous form. It is in a discrete form. Discrete means non-continuous form. Keep in your mind. If atoms and molecules could emit or absorb energy only in non-continuous form, not in continuous form. Okay. So what happened? The scientists gave the name quantum to the smallest quantity of energy that can be emitted or absorbed in the form of electromagnetic radiation. Okay. So this is the thing. Okay. What is the thing, guys? This is the thing. See, atoms or molecules atoms or molecule could possible they can absorb or they can emit radiation. Okay, but if atoms or molecules are absorbing or emitting any radiation or any energy, it can only possible they will do in a non-continuous way, not in a continuous. Okay, so what will happen if they will do in a continuous means we have a big amount of energy because we are doing continuous emission, so it will be a big amount. Okay, discontinuous means that's called a small amount, so that small amount is given the name quantum by the scientist. Okay, so this is the thing. What again I will tell you guys, see, atoms and molecules also could emit or absorb energy. If atoms or molecules could emit or absorb energy, they will only do in a non-continuous form, not in a continuous form. Okay, first thing, so he gave the name quantum. Quantum means what? If they are doing in non-continuous, so it is a very small. Non-continuous means what? You are not in a continuous. You will do one, then next time you will not emit. Then again you will emit, then not emit. Then again you will emit, then you will not. So what is happening? There you will get a small quantity of energy. So that the scientists get given the name quantum. The scientist gave the name quantum to what? To smallest quantity of energy that can be emitted or absorbed in the form of electromagnetic radiation. Guys, everything will happen in the form of electromagnetic radiation, correct? Because electric field and magnetic field should have to be there, and whatever they are emitting, that's called radiation. Okay, so it in the form of electromagnetic radiation is compulsory, correct? Understand? So again I will tell you once again, atoms and molecule also possible that they can emit or absorb energy, but if they are emitting or absorbing energy, it is not in a continuous form, it is in a discontinuous form. So whenever they will do in a discontinuous form, that's called a small quantity of energy. The small quantity of energy, the scientist has given the name quantum. Quantum is what? To the smallest quantity of energy that can be emitted or absorbed in the form of electromagnetic radiation. Understand? Yes, sir. Now if I am talking about smallest quantity of energy that can be emitted or absorbed, so sir, how to find the smallest quantity of energy, how we can emit it or how much we absorb? So there is a formula, this E is equals to H into frequency. See, energy of the quantum, energy of quantum means what? Quantum means what? Are bolo re pyare. Yes sir, quantum means what? The smallest quantity of energy, either it is emitting or absorbing. The smallest quantity of energy, either it is emitting or absorbing, that is called quantum. So how much smallest amount of energy it is releasing or absorbing, so we have to know. So for that formula, for that we will use this formula, energy equals H into nu. H is nothing but guys is called as Planck's constant. Why Planck's constant? Because this theory whatever we are learning is given by Planck's, and V is nothing but frequency. Okay, see here, which theory we are learning? We are learning about this Planck's. देखो भैया, अरे ओ प्यारा देखो ना जी, particle nature of electromagnetic radiation is given Planck's quantum theory. So everything we are learning is about Planck's quantum. Okay, so that's why Planck's quantum, they are given the name quantum. Okay, so the energy, see, energy of quantum is what? Is given by H equals, sorry, E equals H into nu. So H is what guys? See here, nu is nothing but the frequency. H is what? H is the proportionality constant known as Planck's constant, and the H value will remain fixed. This value will never change. 6.626 into 10 to the power of minus 34 joules second. Okay, this is the energy of quantum. How much, you know, the with which energy the light is emitting or with which energy the light is absorbing. Okay, so that energy if we have to find, we will use this formula, H into nu. Nu is nothing but frequency and H is a Planck's constant. Planck's constant value will remain fixed, 6.626 into 10 to the power of minus 34 joule second. Okay, and this frequency they will give in the question itself, so we will find it. If suppose guys another formula is there, देखो another formula, E equals H, because this formula will remain, sorry, this value will remain same guys. See now guys, how we will write the frequency? वी नो दिस हियर, देखो भैया, अरे ओ प्यारे देखो ना जी, अरे देखो ना भैया, देखो ना गाइस, फ्रीक्वेंसी इज व्हाट, देखो c by lambda, फ्रीक्वेंसी इज व्हाट, c by lambda. If suppose c by lambda, देखो c by lambda, c by lambda, तो here in place of frequency I will write c by lambda. Now suppose in the examination guys, two condition is there. If they will tell you to find the energy, and frequency is given, then we will use energy equals Planck's constant into frequency, h into nu, khatam. If suppose they will tell you to find the energy but wavelength is given, find the energy, wavelength is given, so guys we will use the formula Planck's constant into means h into c by lambda, because c by lambda is nothing but frequency. So we are not creating any new formula, from the same formula I am writing this formula. Just the difference is you have to know which we have to use when. If just they will give the frequency and they will tell you to find the energy means h into nu. If they will give the wavelength and they will say to find the energy means h into c by wavelength. Okay, c we know, speed of light 3 into 10 to power of 8 meter per second. H we know, Planck's constant value will remain same. So h and c value is constant. Lambda whatever they will give in the question, we will use it. Khatam. So this is the formula guys. Yes sir. Another formula also I told you, you can write it. Now guys, next we are going to learn about this photoelectric effect. If you know guys, I explained you the half of the photoelectric effect, what will happen. See here what will happen. Electrons were ejected when certain metals, I said now I will take the metal, and what will happen, I will hit with a ray of light. So when I will hit with a ray of light with a metal, electrons will eject. That's why they said electrons were ejected when certain metals were exposed to the beam of light. Beam of light means ray of light I will hit here. So this phenomenon is called photoelectric effect. Understand? Yes sir. See here, देखो इधर what is happening, this is a metal surface, this is a metal surface, correct, metal surface. Light ray, see light is coming in the form of wave. Light ray is coming and hitting to the metal surface. So what will happen, the electrons are ejecting. This is called photoelectric effect. Okay, and then whatever the electrons are ejecting, it is the electrons are negative charge moving to the positive charge, and it will hit here, it will detector, it will show that okay electrons are coming. So meter will start deflecting. So what will happen, current will start flowing. Okay, so that's why what, photon means what, light. With light we are producing the electric, the photoelectric effect. Okay, this is the basic concept we know. Now very important thing guys we have to know here is metal surface, I am hitting with a ray of light. So now think, if I am hitting with a ray of light, or we call it the beam of light, if I am hitting with a beam of light, will it be possible that every electron will come out? No sir. See here, like suppose 10 students are there. Okay, if I am teaching with us, if I am scolding with the same frequency, if suppose 10 students are there in a class, if I am scolding everyone with the same frequency, so those who are soft heart, like those who are very what you can say, soft heart person, what will happen, that person will go out of the class. Correct, the same thing, when I will start hitting with a beam of light, what will happen, the electrons which are attached soft, weak, it will start ejecting from the metal surface. Correct, but still the electrons are here, means still the students are sitting in the class. Correct, suppose 10 students are there, I am scolding with the same frequency. So what will happen, the student who are soft, means soft nature and all, they will easily leave the class. But still suppose out of 10, 4 students were there who was soft nature, they leave the class. But what will happen to the other 6 students? They will not leave. They are like, no sir, if this much frequency you will scold, it is nothing for us, nothing matter for us, we will not leave the class. So like that only the electron will say, oh bhaiya, if this much beam of light you will hit now, other those who are the soft, they have left, but we are hard, we are not going to leave. So what the thing I have to use is threshold frequency. Threshold frequency means guys, the minimum frequency, threshold frequency, understand guys, very important. Minimum frequency, with minimum frequency required to remove the electron. Means see, every electron is having its own frequency to get out. Correct? Every student is having the own scolding frequency to get out of the class. Correct? So like that only, we should not have to hit with only normal frequency. No, we should have to hit with the threshold frequency. So threshold frequency means what? Minimum frequency we have to hit, so that's why electron will eject from the metal surface. That's called threshold frequency. Threshold frequency means what guys? With a normal frequency, all the electron will not go out of the metal surface. So what we have to do? We have to use a threshold frequency. Threshold frequency means it is the minimum, means at least that much frequency should have to be there. Minimum frequency we have to hit to the metal surface. So that's why electron will start ejecting. Correct? Like a minimum scolding, that much high scolding should be there. Then only all will leave. Okay, so that is called the threshold frequency. Again, I am telling you. Normal beam of light I will hit, so all the electron will not leave guys, because every electron have a different frequency to move out. So what will happen? We will use a minimum frequency of light. That's called minimum frequency of light is called threshold frequency. Okay, so what we are going to do? We are using a minimum frequency of light. We will hit with a minimum frequency of light. So that's why electron will eject from the metal surface. So that minimum frequency is called threshold frequency. Means if I am applying the any frequency less than minimum frequency, means electron will not come out. If I am applying any frequency which is less than minimum frequency, electron will not eject from the metal surface. So what we have to do guys? We have to apply the frequency which is equals to minimum frequency or which is more than minimum frequency. Then only the electron will eject from the metal surface. Okay, understand? So that frequency we have to apply is threshold frequency. If any frequency you are giving and it is less than threshold frequency, means less than minimum frequency, electron will not leave the metal surface. Then what will happen? No current will flow. Okay, if we are giving the threshold frequency or frequency higher than threshold frequency, means higher than minimum frequency, then only the electron will eject from the metal surface. Then only current will flow. I hope concept got clear guys. Okay, when the current will flow, when the electron will leave, it's not that guys only I will take a beam of light, I will hit the metal surface with a beam of light with any frequency and electrons ejecting. No, electron is also having attitude. Okay, electron is also having attitude कि भैया नहीं जाएंगे हम. You have to hit with threshold frequency. Threshold frequency means minimum frequency required to remove the electron. So you have to hit with threshold frequency. If you are applying the frequency which is less than threshold frequency, we are not going to leave. Do whatever you want to do, will not leave. So you have to apply the frequency which is equal to threshold frequency or which is higher than threshold frequency. Then only bhaiya electron will like bhago. They will jumping gili chu. So frequency should be equals to threshold frequency or higher than threshold frequency. That we also say that frequency should be minimum frequency or more than minimum frequency. Then only electrons will run away. Okay, see, if you want to kick someone out of the life, that normal frequency will not work. So that threshold frequency, then only that person will go. So equal to threshold frequency or higher than threshold frequency. Equal to same frequency, you will write the threshold frequency, you will fight, or higher than the threshold frequency. Then that person will leave your heart, and that person will say अच्छा चलता हूँ दुआओं में याद रखना. Guys, chalo, we will read this. This is the result what we observed from the photoelectric effect. In the examination they will ask the result. Bhaiya, this you have to write the observations or the result from the photoelectric effect. Okay, and this diagram is there guys. You have to draw this cathode ray. Okay, this you have to diagram hai bhai. Okay, for the what you can say, this is the diagram for photoelectric effect. डायग्राम कर लेना भैया, डायग्राम बनाना जी. ओके, Okay, so I will underline this important equipment for setting the photoelectric effect. Okay, so now see here guys, one more thing is there. If I am hitting with a frequency less than threshold frequency, I know guys, if it is coming, the beam of light is coming and it is hitting to the electron here. Okay, see here, I will draw here, इसको समझो guys, इसको समझो अच्छा से समझो जी, देखो. If guys I will draw a metal surface, if I will draw a metal surface, okay, in the metal surface what is present? Electron is present, electron is present in the metal surface, electron is present. Okay, so now think here, if the ray of light is coming and hitting here, means what will happen? Ray of light will collide with the electron, correct? Ray of light is hitting here, means ray of light is colliding with the electron, yes or no? Yes sir. Ray of light is hitting means what? Ray of light is colliding with the electron, yes sir. If the ray of light, this is a ray of light, if ray of light frequency is less than threshold frequency or less than minimum frequency, nothing will happen, electron will not leave, correct? So we have to apply the frequency which is equal to threshold frequency or higher than threshold frequency. Then what will happen? If I am applying the beam of light, its frequency is equal to threshold frequency or higher than threshold frequency, what will happen? देखो भैया, this ray of light will come and this ray of light will hit to the electron. So what will happen? This will collide with electron. So what will happen? Electron will start ejecting from the surface. Electron will start ejecting from the surface. The electron is start ejecting from the surface means what? Electron is moving. Correct? Electron is moving out of the surface. Electron is moving out of the surface. If electron is moving out of the surface means what? We know some velocity is there. Correct? So some velocity is there and movement is there, means which energy will come? Kinetic energy. Means the electron is moving with some kinetic energy. Correct? Yes sir. So this is the thing guys, that's why see, you can see electrons are ejected from the metal and are counted by detector that measures their kinetic energy, because electrons are leaving with the kinetic energy. Okay, yes sir. So guys, same thing you can read and that's done. See here, the electrons are ejected from the metal surface as soon as the beam of light strike the surface, means there is no time lag between the striking of light beam and ejection of electron from the metal surface. Time lag is zero time, no time, as it will hit it will leave far like this. Next is what? The number of electrons ejected is proportional to the intensity of brightness of light. As I said guys, if the intensity of light is more, the electron release is more, correct? So what intensity we want? We want with threshold frequency. They said for each metal there is a characteristics minimum frequency, also known as threshold frequency, below which photoelectric effect is not observed, because below which electron will not eject. No electron eject means no electricity, so no photoelectric effect. So at the frequency is greater than threshold frequency, the ejected electrons come out with certain kinetic energy. Just now I explained, the kinetic energy of these electrons increases with increase of frequency of light, correct? So guys see, the normal frequency whatever we have to use, it should be greater than threshold frequency. This is guys mu naught, this is called threshold frequency. So whatever the frequency we are using, it should be greater than threshold frequency. Then only what will happen? The electron will start releasing at faster rate. If electron is moving out, what will happen? Kinetic energy will also increases. So if number of electron is increasing, kinetic energy is increasing. So how the number of electron increases? With the intensity of light. See, if the intensity of this incident light, if the intensity of this incident light is very high, what will happen? The electron ejected is also very high. If electron ejected is very high, so kinetic energy is also very high, because electron ejecting with a very fast, if intensity is high, so what will happen? Electron ejecting is very high. If electron ejecting at faster rate, kinetic energy is also faster, because kinetic energy depends upon speed. I hope this point is clear, guys. Okay. Same thing, guys, what just now I explained, just now what I explained, this concept, it is the same thing here. See, shining a beam of light, shining a beam of light is nothing but the beam of light will come here, okay, and hit to the metal surface. Okay, so shining a beam of light onto a metal surface can therefore be viewed as a shooting beam of particles. Correct, the beam of light is hitting to the, this beam of light is hitting to the metal plate. What we can see it as a shooting of beam of particle, will shoot to the metal surface. Correct. The photon means what? The beam of light which is shooting to the metal surface, that beam of light is called as photon. So when a photon of sufficiency, photon means what? Photon means, guys, if they'll ask in the examination define photon, you will write the simple thing is, when a beam of light hitting to the metal surface, that beam of light is called photon. Okay. So when a photon of sufficient energy, again, not every photon will release the electron. Photon of sufficient energy strikes an electron in the atom of the metal, it transfers its energy to the electron. Obviously it will hit to the electron, this beam of light will transfer the energy to the electron. During the collision, an electron is ejected without any time lag or delay. As I said, guys, it will hit, it will collide with the electron, and electron will start releasing without any time lag or delay. Greater the energy posed by the photon, greater will be the transfer of energy to the electron, and greater the kinetic energy of ejected electron. Correct. In other words, kinetic energy of ejected electron is proportional to the frequency of electromagnetic radiation. With what frequency I am putting? Higher the frequency, higher the intensity. So what will happen? Higher the collision, and then higher the electron will start releasing out. So higher the electron will start releasing out, higher the rate, higher the speed, higher the velocity, because velocity depends upon speed. Done. Now I see H naught, I know threshold frequency. So threshold frequency is also called as work function, W naught, both are same. So kinetic energy of ejected electron, see, we know that electrons are ejecting with kinetic energy. What kinetic energy? So guys, देखो, kinetic energy of ejected electron formula is this. H means this, guys. लिख लेना हो भैया, ओए लिखो इधर. Write on this, guys. Write on this for here. Write on this, na. Kinetic energy of ejected electron is given by, write on this for here. Like this. Write on. Kinetic energy is what, guys? Kinetic energy equals to energy minus threshold energy. Energy minus threshold energy. So energy is what, guys? Energy formula just now we studied, H into frequency. Minus threshold is what? Threshold frequency we know, guys, H into mu naught. Okay, yes sir. So guys, what is the, you can write like this, H Planck's constant is a common, I take a common, so mu minus v naught. Okay, so kinetic energy is what, guys? Half mv square. M is what? Mass of electron. Half into mass of electron, and with which velocity the electrons are coming out. So kinetic energy is what? Half mv square equals H into mu minus mu naught. Okay, this is what the kinetic energy of ejected electron is given by. Now see, guys, here, this thing what I have written, this thing, you can write like this also. See here, kinetic energy is half mv square, you send this side, hv, h nu minus h nu naught. See, see h, अरे भैया आजा, see h nu minus h nu naught. Okay, the same thing. This, so in the examination, if they will ask the kinetic energy of ejected electron is given by equation, please write on this from here till here. This is the correct answer. Okay, then you will get the full marks. Okay, so this is what, guys, this is the kinetic energy. You have to write exactly as it is. Okay, don't remember this, better remember that only. Next is, guys, you will see the dual behavior of dual behavior of electromagnetic, this is nothing else, just we learned, this is a quick revision. Dual behavior of electromagnetic radiation, we studied about the wave nature, we studied about the particle nature, same thing, it is an overview. Okay, see, dual nature of electromagnetic radiation is what? The particle nature of light pose this is important here, means nothing bhaiya, simple cheez dekho idhar. Dual nature of electromagnetic radiation, the dual nature of electromagnetic radiation, we will see this green part now, it's like a what the, you know, what the difficulty they faced and how they overcame, what the difficulty they faced and how they overcame. Okay, this is the last, guys, this is the last page, we are stopping it here. After that we'll solve this problem, 1 2 3 problem, 4 problem, then we'll stop it. Okay, so dual nature of electron, see, I know notes is nothing much, guys, notes is nothing much, the thing is explanation, because once you understand, easy peasy. See, you will get feel it very easy, guys, for your this, what is a competitive examination. See, if you will think now like sir is joking and all, I will show you. Ruko structure of it. See, this I kept. See this for the JE. See, for the JE class 12th I am doing this electrochemistry chapter. So after the chapter will get over, now we will start doing this modules. Okay, then same, that was the JE, this is one NEET class 12th electrochemistry, so we'll do together. See, for you all I have written, I have kept, guys, I have written, I'm saying I have kept. Kidhar gaya bhai, abhi rakhe tha. So we will do that also, we will do, don't worry about that. Okay, we will do, sorry guys, sorry. See, I have this much book. So what are you thinking? I keep on solving, भाई तुम लोग के लिए सब चीज करना पड़ता है. तो देखो इधर, this one. Okay, yeah, see here, this is for NEET class 11, grade 11, structure of atom. This will get over now, you will get everything easy. And next is here, JE class 11, structure of atom. So JE, KCET, NEET, all will be like, almost similar for the chemistry. Okay, so now see, we will see in the dual behavior of electromagnetic radiation when they are explaining now to what the difficulty they find. The difficulty they find is the particle nature of light posed a dilemma for scientists. What they pose is a dilemma for the scientists, that first drawback means fast, like, not a drawback, you can say the first difficulty what they are facing is, on the one hand, it could not explain the black body radiation and photoelectric effect satisfactorily. First thing, what, guys, it cannot able to explain the black body radiation and it is explaining the black body radiation and photoelectric effect, but not satisfactorily, guys. It could not explain the black body radiation, and it can able to explain the black body radiation and photoelectric effect, but it could not explain black body radiation and photoelectric effect satisfactorily. That is the important thing, first point. Second point, on the other hand, it was not consistent with the known wave behavior of light, which could account for the phenomenon of interference and diffraction. Interference and diffraction you are going to study in the physics. Okay, so these two drawbacks what they are facing for the dual behavior. If they will ask now, dual behavior of electromagnetic radiation, what are the drawbacks or limitations what they are facing? So these are the two limitations you will write. Okay, first limitation, the black body radiation and photoelectric effect, it could not explain the black body radiation and photoelectric effect satisfactorily, first drawback. Second drawback you will write, it was not consistent with what? Known wave behavior. Known, whatever the wave behavior we know, we cannot able to know that. Known wave behavior of light which could account for the phenomenon of interference and diffraction. This was the limitations what. But what they overcame with that. See, the only way to resolve the dilemma was to accepted the idea that light possesses both particle and wave like properties. That is, light has dual behavior. So understand why the scientists did all these experiment, photoelectric effect, black body radiation, then the wave behavior of light, everything they did, but still they saw that, oh my god, this particle nature of light, particle nature of light is not satisfying. Particle nature of light is not, see, understand one thing, 1 minute, listen. Scientists did everything. It did the black body radiation, they did the photoelectric effect, they did the wave behavior of light, everything they did. But last, when they saw about the particle nature of light, they got the dilemma. They are like, oh shit, the particle nature of light starts showing the drawback. What the particle nature of light starts showing the drawback, the dilemma is, it could not explain the black body radiation and photoelectric effect satisfactorily. Then next is what? It was not consistent with the known wave behavior of light, which could not account for the phenomenon of interference and diffraction. When they saw that this much again drawback is coming because of particle nature of light, they are like, भैया छोड़ दो, आधा जिंदगी खराब हो गया इसको निकालने में. उसके बाद भी when we studied about the dual behavior of light, wave is showing proper wave behavior of light is nothing good. When we'll see about the particle nature of light, it starts showing the drawback, that black body radiation photoelectric effect cannot able to justify the satisfactorily. Then it could not explain about the behavior of light for the interference and diffraction. So what they did, they like, no, now we cannot able to do, and now we will not do at all. What they said, that the only way to resolve this dilemma was, they accepted the idea that light possesses both particle and wave like properties. They said that light has both dual behavior. Okay, how they possess it, understand? Now guys, we will solve the problems, not your life problem, this problem. Okay, so see, they said very important and very easy thing. Okay, before this guys, I will give you one thing. देखो इधर, easy to understand guys, आराम से समझेंगे. Two things I am giving you. Okay, देखो इधर. Okay guys, see, first thing what we get to know, is no, wait. Here, see the relation, understand the relation guys, not yours, not mine. Here, understand, see, we know that guys, how much energy the black body energy absorbed, that much energy it released, that much energy black body released, correct? Yes sir. How much energy the black body is absorbing, sir, that much energy it is releasing. So how much energy? H mu. Let's suppose I will take that H mu 1, because absorb now, released I will say that H mu 2, correct? How much it absorbed energy, that much energy it released. Okay, so see the relation, see the, understand the relation. So guys, what we will see here, if we will see the relation of energy absorbed and energy released in the terms of wavelength, so what will happen? Wavelength for the absorbed is equals to the wavelength for the released. But same, if you will see the energy absorbed and energy released, the relation for you want to see for, sorry guys, if you want to see the relation for energy absorbed and energy released for frequency, if you want to see the energy absorbed and energy released for frequency, so what will happen? If energy absorbed and energy released, if you want to see for frequency, so equal, absorbed energy frequency is equals to released energy frequency, because see, they both are equal, correct? But the same thing, if you will see the energy absorbed and energy released for the wavelength, so wavelength means, how you will write the hc by lambda, correct? Because frequency is what? C by lambda, and this will be what? hc by lambda 2 means what guys? hc the common, it will get cancelled. Here also h will get common, it will get cancelled. Means what we are getting, see here, energy absorbed and energy released for frequency is what? Frequency 1 equals to frequency 2, correct? It is same. But same guys, if energy absorbed and energy released, if I want to see for wavelength, so what will happen? It is in the form of 1 by lambda equals to 1 by lambda 2. Okay, it is in the form of reciprocal. Okay, same thing guys, if you want to see the energy released and energy observed, energy released and energy observed in the terms of wave number, guys, we know 1 by lambda is what? 1 by lambda is wave number. 1 by lambda is wave number, guys. Wave number is what? 1 by lambda, correct? 1 by lambda is what? Wave number. So what will happen? Wave number 1, which is equals to, this is what? 1 by lambda is what? Wave number 2. This is the relation you have to understand. Okay, so when energy observed, when energy released, you will talk the frequency are equal, wave number are equal, wavelength are reciprocal. Important, लिख लेना भैया. And the one more thing is, guys, see here. One more thing is, we know this guys, we know this. Okay, beam of light, if its intensity is high, bolo re pyare, if beam of light intensity is high, so what the energy will be high, right? The energy with what it will hit, the energy is higher. So if energy is higher means what? Electron rate is releasing also is higher, means what you can say, kinetic energy is also higher. It's all depend directly proportional, correct? Yes sir. Now guys, see, if I'll talk about unit of energy, ये important है भैया, लिख लेना कहीं पर भी. This is okay fine, but this is important. Unit of energy. अरे ओ प्यारे देखो जी, unit of energy guys, देखो, I know guys the time is almost 2 hours. Okay, but what can I do guys? I'm doing for you all. I have to also do for the 2 hours continuously, so no option. Never see and sit for the time guys, just see and sit for the concept. Okay, if you see the time, never you will understand, never you will learn, because I'm not teaching, you know, like over, like, you know, up. I'm not going in a deep and all. No, I'm teaching you in a deep, so it will take a time. Okay, so understand the thing. I'm not teaching you over. If I want to teach over, now this chapter will get over in, you know, 5 or 6 hours, but I'm going in a deep, so it will take time. Okay, because if you will go in a deep, then good for the competitive exam also, and you have to write competitive exam. But yeah, KCET at least you will write, and need be. So guys, see, unit of energy. If I'll talk about unit of energy, now the unit of energy we will write in terms of joule. We will write in terms of joule. We will write in terms of joule. So see here guys, if they will give in terms of calorie, so 1 calorie is what? 4.2 joule. See, unit of energy we are going to keep in terms of joule. In terms of what? In terms of joule. So if they will give 1 calorie guys, 1 calorie is equals to 4.2 joule, the conversion. And see, 1 electron volt, if they will give electron volt, the 1 electron volt is what? 1.6 into 10 to power of minus 19 joule. Okay, now suppose many time in your competitive exam, not in your board exam, in your competitive exam, what they will say now, they will say you to find the energy in electron volt, find the energy in electron volt. This will be using for the competitive examination, not for your board. Your competitive exam के लिए, NEET के CET के लिए. If they will tell you to find the energy in electron volt, so directly we will use guys energy in electron volt. So we will see that directly we will use 12,400 divided by lambda. If lambda is given in nanometer, this 1240 divided by lambda, if lambda is given in nanometer. Otherwise 12,400 divided by lambda is given in angstrom. Okay, that's khatam. Okay, if suppose you will say the frequency is given, then frequency is given, then we will find the lambda. Now lambda is equals to c by frequency. We will find the like lambda from here, and then we will substitute it. We will see that lambda is in Newton meter, we will use this formula. If lambda in angstrom, we will use this formula. Very important formula भैया, NEET के CET JEE सब में पूछता है. Okay, yes sir. Now guys, we will come for the problem. See, they said calculate energy of 1 mole of photon. Calculate energy of 1 mole of photon. Guys, we know very simple thing. They said 1 mole. 1 mole. Mole means what will come? Molecules. Molecules means particles, like Avogadro number will come. Okay, see here. Calculate energy of 1 mole of photon of radiation whose frequency is given. Guys, for finding the energy of just photon, for finding the energy of photon, what we know? Energy of photon is equals to, sir, h into frequency. So h is a Planck's constant, we know value 6.626 into 10 to the power of minus 34. Frequency we know into 5 into 10 to the power of 14. Now if see this formula, what I have written, this formula I have written just energy of photon. Okay, see, energy of 1 photon, the energy of 1 photon equals to h mu. We'll substitute the value, we will get energy of 1 photon, but we have to find energy of 1 mole. Energy of 1 mole, guys. In the examination they will just say, calculate the energy of photon or energy of 1 photon. We will use this formula and we will substitute the value, we will solve it, khatam, we will get the answer. But if they will say calculate the 1 mole of photon, because see, this same question you will get in the KCET. Okay, this question they ask in the NEET. Okay, this question they asked in the 2.6, they asked in the KCET. Okay, so if they will ask you calculate energy of 1 mole of photon, so 1 mole of photon, what you will do, guys? First we will find the energy of 1 photon. Okay, energy of 1 photon into 1 mole means what? I have written in Avogadro number. We will multiply with this 6.022 into 10 power of 23. You will get it. So energy of 1 mole of photon, what is the formula? The energy of normal photon into Avogadro number. That's it. We'll get the energy of 1 mole of photon. Okay. Then problem 2.7. problem ही problem है, solution का पता नहीं. Solution मिला तो साला question क्या था पता नहीं. देखो इधर. They said a 100 watt bulb. 100 watt bulb means what, guys? Power is given. Power of bulb is 100 watt. I am not going to change anything. Just see. Emits monochromatic light of wavelength. Wavelength is given, guys. Okay, we know that wavelength is given. Calculate the number of photons emitted per second by bulb. Guys, number of photons emitted. Number of photons emitted. So see, number of photons emitted. What is the formula? Number of photons emitted is this. Power divided by this one, energy of photon, h mu. This is the formula for finding the number of photons, power divided by h mu. So they said calculated emitted per second, guys, per second. So what we will do, power of the bulb is 100 watt, will convert into joule per second, it will remain same, 100 joule per second. Okay, we get to know power is 100, so I will substitute the power as 100. See, number of photons, what is the formula? This power which we got 100, correct? Power, the power which we got 100 divided by, we have to find energy of photon means what? E equals h mu. But mu is not given, guys. Wavelength is given to hc by lambda. So h value we know constant, c value we know speed of light, lambda is given, we'll write in terms of meter, 10 to the power of minus 9 meter. Then we will get this energy. Just substitute it here. This fine. Khatam. Right? Yes, sir. Now we will see the, guys, try it. 2.8 you try by yourself, you'll get the answer. 2.8 you try by yourself. Okay, because 2.8 they won't ask in your examination. 2.9, because 2.8 for CBSE, like, okay, 2.9 देखेंगे. 2.9 is what, guys? The threshold frequency V0. Again, we know threshold frequency is V0. For a metal is this much, so V0 is given, guys. V0 is given. Okay, they said calculate the kinetic energy of an electron. भैया kinetic energy is said. अरे ओ बाबू भैया, kinetic energy we know ना, h mu minus mu naught. Just now we got correct. See here, kinetic energy they are writing same thing, equals to h mu minus mu naught. We got it here ना. देखो kinetic energy equals to what? h mu minus mu naught. खत्म. This is what? This is kinetic energy on h mu minus mu naught. Okay, so h is what? Planck's constant. Correct. H is what? Planck's constant. See, we'll use h mu minus mu naught. H is what? Planck's constant. They had given mu naught is what, guys? See, mu naught they had given. In place of mu naught, we'll write this 7.0 into 10 to the power minus 14. Then calculate the kinetic energy of electron emitted when radiation of frequency. Mu is also given. Mu also will substitute. That's it. When you will calculate, you will get this answer. Khatam. How to do the calculation, guys? I will tell you. See, kinetic energy equals to H into mu minus mu naught. H is what? Kinetic energy. H we know bhaiya, Planck's constant is 6.626 into 10 to the power of minus 34. Ab mu dekho, let's see the mu. Mu means what? Mu they had given 1.0 into 10 to the power of 15. Oh ho ho ho. 1.0 into 10 to the power of minus 15. Oh ho ho ho. Minus mu naught. Mu naught dekho bhaiya. Mu naught is 7.0 into 10 to the power of 14. I know it is not minus, it is plus. I know bhaiya, I know. Sorry guys. It is what? कितना था भाई? 7 into 10 to the power of 14. 7.0 into 10 to the power of 14. Now guys, see, simple thing what we will do is, every time guys, see, this 10 to power should be same. This 10 to power should be same. So what we will do, guys, this is 15, this is 14. I will make this 15 to 14, means we have to do minus 1. So when it will become minus 1, when this point will go towards right side, so it will become 6.626 into 10 to the power of minus 34. This will become 10.0 into 10 to the power of 14. Understand, guys? Oh bhaiya, are oh pyare, whenever you have to do this na, keep this 10 to power should be same. What we have to do, guys? We have to keep the 10 to power should be same. So 10 to power should be same, mean this is 14. Let's change this also to 14. So we have to do minus 1. Minus 1 means bolo re pyare, this will go towards right side. So 10.0 into 10 to the power of 14 minus 7.0 into 10 to the power of 14. Correct. See guys, 10 to the power of 14, 10 to the power of 14, it will come outside. So 6.626 into 10 to the power of minus 34. 10 to the power of 14, 10 to the power of 14 will come outside. So I will write into 10 to the power of 14. Inside is what? 10 minus 7. So 10 minus 7 is what? Bolo bhaiya, 3. So 6.626 into 3 into C. When bases are same and it is multiply. See, when bases are same and it is multiply, what will happen? We know power will get add. So minus 34 and plus 14. How much it will be? 10 to the power of minus 20. If you don't know, bhaiya, use a calculator. Okay. This is there. This will become 3. So the number will multiply with number 6.626 into 3. Okay. You multiply with the calculator, you will get some number into C. 10 to the power of minus 34 into 10 to the power of 14. So what will happen? See, when bases are same and it is multiply, so power will get add. So 10 to the power of minus 34 plus 14, how much it is there? So bhaiya, 10 to the power of 20. So like this you will get the answer. Correct. I know the simple calculation you can do. So they have written 10 to the power of minus 19 mein. So no issues guys, you will get minus 20. Minus 20, change it. This is for the today's class, guys. I know it is bit lengthy, but bhaiya, we can't do anything, guys. Okay, because I am teaching you in a depth and detail. If I will not teach you in a depth and not detail, it will get over very fast in 1 hour maximum. Okay, but it takes around 2 hours for 15 minutes around that, because I'm teaching in depth and detail. So guys, don't see about the length of the video, just see the depth of the concept, guys. Understand the concept, bhaiya. Okay guys, thank you, bye bye, we'll meet in the next video.